At 4:53 p.m. local time earlier today, a major magnitude 7.4 earthquake struck offshore northern Japan, specifically 100 kilometers east-northeast of the city of Miyako. As the ground started to shake back and forth over a wide area, power outages were triggered, items fell off of shelves, and buildings shook, but strangely enough, the earthquake was quickly over. In fact, it only lasted 12.1 seconds, being at least 35% shorter than the expected duration of similar earthquakes of this magnitude. Regardless, some highly scattered damage did occur, and there were only a few minor injuries reported, with thankfully no deaths. However, because areas adjacent to the earthquake epicenter moved by up to 4.7 meters or 15.4 feet in such a short period of time, this motion and the related ground shaking was able to displace overlying ocean water, despite the fact it appears as though no part of the fault plane ruptured onto the ocean floor. This generated a tsunami, which was initially feared to have the potential of being up to 3 meters or 10 feet in height. However, what ended up striking was significantly less than this, reaching maximum heights of 80 centimeters or 26.5 inches, while also affecting a lesser extent than initially expected. And yes, this background footage is video of part of the low-height tsunami striking. By the way, don't ever get this close to the shoreline if a tsunami is expected to soon strike, and definitely don't film a tsunami. Nevertheless, the unusually brief earthquake threw a wrench in initial damage modeling, meaning that compared to what was initially forecasted, the peak ground acceleration was higher than expected, but caused far less damage, while also causing a smaller height and more limited extent tsunami. In other words, some form of damaging tsunami and more extensive structural damage would have likely occurred in my opinion if today's earthquake hypothetically had double its actual duration. I also want to note that some landslides and liquefaction may have occurred, but I have not seen confirmation of either. So, what exactly caused today's earthquake, and why are there mentions of an increased risk for a magnitude 7 or larger quake in the next week? Portions of Japan lie on sections of 5 tectonic plates, and as a result, there are numerous zones where collisions between these are occurring. Offshore of northern Honshu, the tectonic collision specifically involves the Pacific plate, which is subducting underneath the Okhotsk plate. Over time, stress builds on the overlying Okhotsk plate due to friction from the subducting plate pulling it downwards into the mantle. This stress builds up until a section of it overcomes the friction being applied to it, causing what was likely around a 70-kilometer long and 35-kilometer wide portion of the Okhotsk plate to snap back upwards. This motion by definition involves a thrust fault, and due to its location and magnitude, such events can be considered as megathrust earthquakes. The main reason why there are mentions of an increased risk for another magnitude 7 quake, or perhaps even larger in the vicinity during the next week, is simple statistics. Anytime a large earthquake occurs, the chance of a similar or even larger earthquake striking temporarily increases. However, this risk rapidly decreases the more time progresses from the original event. In other words, by far the most likely scenario is that no quakes of that magnitude follow in the next week nearby. Also, there are 3 segments of Japan's megathrust boundaries deemed at increased potential risk for producing a magnitude 8.0 or greater megathrust event by 2055 when compared to other areas. The latest quake which struck was located within one of those 3 zones, although I wouldn't read too much into this. Since the 1968 magnitude 8 range quake in this particular zone, magnitude 7 range earthquakes have occurred 6 other times, and none of these triggered a magnitude 8.0 or greater quake. Aftershocks, regardless, are to be expected, although most probably lower in magnitude, and already 4 magnitude 5 and 3 magnitude 4 aftershocks have struck. Aftershocks typically decrease in frequency as the time since a main shock increases, typically at a 1/x rate if x represents time. Stay tuned for more updates. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.